Good morning and welcome back. Today we are going to be talking about 10.6, converting complex. And when we're talking about complex numbers, I'm guessing you remember those from Algebra 2 or possibly even before that, but complex numbers involve our i's here, right? And it's kind of in another dimension is how we think about it. It's kind of hard to visualize, but with our complex numbers, they're typically written in this form: 2 plus 5i, -1 plus 3i, whatever, something, the normal number, and then the imaginary part, okay? So if we look here, if we think of that as an x plus yi, and then in polar, we also can have complex, and they would be r, so the radius, times cosine theta plus I sine theta. Now, the thing that's good about converting these is it's going to be very similar to 10.2, almost identical. The formulas over here you'll recognize, they're the same. It's just where we pull it from that's a little different. Okay, so the first thing I want us to do is practice deciding which quadrant they would be in. Okay, so if we think of this as our x and our y-axis, okay, so plot the rectangular complex points and tell which quadrant the point lies in. So 2 plus 5i. If we think about it, that's going to be to the right because 2 is positive. So I don't need the exact spot, but if it's to the right and up, so somewhere over there in quadrant 1. Now -1 plus 3i, that's left and up, so that's somewhere in quadrant 2. 4 is to the right, negative square root of 5i, so somewhere down here in quadrant 4. And our final one, they're both negative down here in quadrant 3. Now we'll use that information on the back, but for now, it says convert each polar complex number to a rectangular complex number. So if we look here, the polar complex number, this is what they're given in, and we want to get to a rectangular complex number, so to x plus yi. Now the first thing we need to do is just find what's our x, what's our y. We'll plug in the r, which we can find here at the beginning. They have the same theta, right? So this first problem here, we know that x will equal r times cosine of pi over 6. Meanwhile, y will equal 2 times sine of pi over 6. And we think, and if you need to, you can look on your sheet, what is pi over 6? Okay, so at pi over 6, cosine is square root of 3 over 2. So I like to put the 2 over 1 just to make it a little easier. And at the sine value is 1/2. Okay, so now we can multiply. The 2's will cancel on both of them actually. So x will equal square root of 3 over 1, or square root of 3. Y meanwhile will equal 1. So to write this now, I just want to put this into rectangular complex form right here. So it'll be square root of 3 plus 1i. And that is all we do. Second one, very similar, except now we have a radius of 4. Cosine is at 3 pi over 4. And do the same thing for y. All right, so at 3 pi over 4, it's negative square root of 2 over 2 for x, for the cosine. And for the sine, it's going to be positive square root of 2 over 2. Now if we think about it, 2 goes in 4 twice, goes in 2 once. So for x, you'll get negative 2 square root of 2. For y, you'll get positive 2 square root of 2. And whoops, that's a little sloppy there. But if we add the ion at the end, we will be done. All right, 2 more. Same approach. All right, so at 7 pi over 6, it is going to be negative square root of 3 over 2 for x, for the cosine. And for the sine or the y, it's going to be negative 1/2. Okay, those 2's will cancel, and we know that becomes then negative 3 for the x. Meanwhile, the 2's will cancel, and you're left with just negative square root of 3 for the y. So we will have negative 3, negative square root of 3i. All right, the last one we'll do real quick. This one's maybe a little easier because at 3 pi over 2, you're going to have nice numbers to deal with. So square root of 3 times 0. So at x, it will be 0. For y, square root of 3 times negative 1. So 0 minus square root of 3i. All right, so if we flip to the back now, we'll do the same thing, except we're going the other way. So we're starting in rectangular complex, we're going to polar complex. But right here, we want to plug those in, and we're using the bottom formulas here. So the r squared, this one's pretty easy. The mistakes people were making was when we had negatives. So like on number 6, we'll talk about that in a little bit. But r squared equals 1 squared plus whatever the square root of 3 squared is. So that's 1 plus 3. So r squared will equal 4. We take the square root of both of those, and r will equal 2. Now that's our r value. To decide our theta, let's first decide if it's 1, if they're both positive, it's somewhere up here. So now we do the tangent of theta equals y over x. So square root of 3 over 1. So the tangent of theta equals the square root of 3. We think onto our, so we need to be in quadrant 1. Where is the tangent equal to square root of 3? And that will occur when theta equals pi over 3. If you don't have that memorized, then you just need to look it up on your orange sheet. Okay. So 2 times the quantity cosine of pi over 3. Oops, I don't want a parenthesis there. My bad. Plus I sine of pi over 3. And we're done. All right. Number 6. This one, we had some problems in 10.2, we had problems when there was a negative involved. So keep in mind, it's negative 5 squared. That entire quantity is squared. So it's not going to give us negative 25. It will give us 25. Some of you would have had these cancel out. In fact, they're going to combine to be 50. Okay, we take the square root of that. 50 breaks apart 5 times 10. That 10 breaks apart to 2 times 5. Pair of 5s, that comes out front. The 2 is left inside the square root. Now, negative and then positive, so that's left and up, quadrant 2. Tangent of theta equals 5 over negative 5. That reduces to negative 1. When is it equal to negative 1? And that would be at 3 pi over 4. Keep in mind, there's 2 spots. It's also down here in quadrant 4. It's also equal at 7 pi over 4. But that doesn't help us because we know it's in quadrant 2. All right, so we write it down. Plus I sine. I don't know why I put that there. Oops. 3 pi over 4. And we're done. All right, 2 more. Let's see how long this is getting. So, okay, I'll go ahead and do these quick. So first thing, r squared. So both of these are positive 3. We 9 plus 9, which is 18. Take the square roots of both of those. That breaks apart. 9 times 2, 3 times 3 times 2. Got a pair of 3's, so r will equal 3 square root of 2. Now they're both positive, so it'll be up in quadrant 1. And we know the tangent of theta will equal 3 divided by 3. So the tangent of theta will equal 1. Up there in quadrant 1, that only occurs at theta equals pi over 4. So all we got to do is write it out, and we're done. All right, one final problem here. So we square both of these. And this one's a little easier. We'll get r to be 2. Now it's positive and then negative, so down here in quadrant 4, tangent of theta equals y over x, so negative 1 over square root of 3. Remember, we can't have a square root on the bottom, so we're going to multiply this. We're going to rationalize the denominator, and we'll get negative square root of 3 on top over 3 on the bottom. Okay, when we look, hopefully you see that at theta equals 11 pi over 6. Almost done. All we got to do now, write it out, and we're done. So I know this semester is coming to an end. Finish strong. Please get some work done. If you have questions, let me know, and let's finish things out. Good work, and I'll see you soon. Bye.